Working with exponents. So we're going to move into how to manipulate and do operations when I have exponents. So first thing, let's define a few items. So the 4 in front of a variable, this is called your coefficient. The 5, the smaller number at the top, those are your exponents. Also sometimes called a power. So those can be used interchangeably. Now, whatever the exponent is actually attached to, that is called the base. And so in this case, the x is the only thing that that 5 exponent is attached to, so we call the x the base. If there were parentheses in this example, like this example here, parenthesis 4x to the 5th power, that would mean in this case, the 4 and the x are attached to the exponent of 5 because of the parentheses. So the base now would be 4x altogether. Now, one thing we need to clarify before we get started is the difference between coefficients and exponents. So coefficients represent repeated addition. And so when you would add like terms, you would add up the coefficients. So 1, 2, 3, 4, 5 x's because you are adding all of these x's together. That's what the 5 represents. Now, exponents are similar, but exponents represent repeated multiplication. And so if you're multiplying something over and over and over again, we represent that repeated multiplication with an exponent, similarly like we did with the coefficients. It's just coefficients are repeated addition and exponents are repeated multiplication. So what we're going to do is we're going to be simplifying expressions with exponents and different bases by using what we call expansion. And so we're going to basically break apart the exponent and put it into the longer format of y times itself or x times itself or whatever the case may be. So for example 1, we are going to expand this out in order to simplify. So we're going to make it look more complicated and then break it back down. And so in this little parenthesis, this is y to the 4th power. So that means I have 4 y's all multiplied together. The second parenthesis is still multiplied to the first, but there are 3 y's in this set. So times 3 y's all multiplied together. Then this last parenthesis still multiplied, we have a single y in the third parenthesis. Now that we have expanded out our exponent, so instead of writing it as the condensed version of y to the 4th, we have it expanded, y to the 3rd, we have it expanded, we're going to basically see if we can condense this back down. Well, we know that we can represent repeated multiplication of the same thing with an exponent. So I'm going to count how many times this y is being multiplied to itself, and that will be the new exponent. And so I have all of these y's. So I have 1, 2, 3, 4, 5, 6, 7, 8 y's all multiplied together. So I can simplify that as being y to the 8th power. So we have simplified this expression here, y to the 4th times y to the 3rd times y, into a single y to the 8th. Let's look at one that's a little more complicated. So number 2, negative 3x squared y to the 7th times 5x y to the 6th. So in this case, we have some coefficients along with some exponents and some different bases. So for this first parenthesis set here, I have a negative 3, which is a coefficient, times, and then it says x squared. So this is going to be x times x. And then I have y to the 7th. Y times y times y, 4, 5, 6, 7 times. Then we have the other parentheses still multiplied to the first one, so times a coefficient of 5. We have a single x, and we have 6 y's. 1, 2, 3, 4, 5, 6. So now we look and see, okay, we've expanded everything out. Now maybe I can condense things back down. It's kind of like you can't add an x and a y together. You can't combine x times a y together either. So we're only allowed to condense with the like bases. So for example, all of the x's we can condense down. All of the y's we can condense down. So throughout all of this problem, there is 1, 2, 3 x's all multiplied together. So that gives us x to the 3rd. Now let's count up the y's. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 y's all multiplied together. So that can be condensed into y to the 13th power. Now the coefficients are still out here in the front with the multiplication signs. So the coefficients here are actually going to multiply these together. Can't forget about those. So negative 3 times 5 makes negative 15. And then we still have x to the third and y to the 13th being multiplied out as well. Now let's look at some division. For example 3, we have y to the 6th over y. And so again, we're going to expand this out. So in the numerator, we have 6 y's multiplied together. And then in the denominator, we have 1 y. Now, I'm going to come to the side of this example. We know that anything divided by itself, for example, 2 divided by 2, simplifies down to a 1. So for example, if I had 2 over 2 times, let's say, 3, this 2 over 2 would simplify to a 1, and 1 times 3 is just 3. So this 2 over 2 is extra information that we don't need. Y's and variables work relatively the same way. If I have a y divided by itself, this is really just a 1, and we don't need that extra information. So we can simplify this by getting rid of all of the pairs of y's that will create a 1. So anything over itself. So y divided by y, we can get rid of because it's extra information. Now that's all I'm allowed to get rid of because there's no more y's on the bottom because this one's crossed out. I do have y's on top, but there's no pairs with them on the bottom, so I can't get rid of any more y's. And now we can condense this back down. So we have 1, 2, 3, 4, 5 y's left on the top, so y to the 5th, over, when there's nothing left on either side of the fraction, you put a 1 in its place. And the reason is because there was still 1 times y, it's just nobody writes the 1 in the front. But now that I don't have any placeholders, that 1 needs to come out of the background. I need to actually physically write it down. Although in this case, it's still not really necessary because if you divide y to the 5th over 1, it still makes y to the 5th. So if you have a 1 on the bottom, you don't need this one. Don't need. But if you have a 1 in the numerator, this one you have to keep. You can't get rid of the 1 in a numerator. You can just get rid of the 1 in the denominator. Let's look at number 4. 4x to the third, y, z to the 6th, divided by 16x, y to the 7th, z. So again, we're going to break this apart. So the 4 on the top is a coefficient. We'll deal with him later. Then we have x to the third. So 1, 2, 3 x's. We have 1 y, and we have 6 z's. 1, 2, 3, 4, 5, 6. All divided by 16 is the coefficient. We'll deal with that one later. We have 1x, we have 7 y's, and we have 1z. Now that everything is expanded, let's see if I can maybe get rid of some things. So I see that there's an x and an x, and then there's a y on the top, y on the bottom, z on the top, z on the bottom. Now that I've gotten rid of everything I can, we can condense this back down. So now this turns into 4 on the top, and then we have, let's see, there's 2 x's on top, so that would be x squared. There are no more y's on the top, so now we have z's. 1, 2, 3, 4, 5 z's at the top, so z to the 5th power. And then at the bottom, we have 16. There's no more x's in the denominator. We do have a bunch of y's, though. 1, 2, 3, 4, 5, 6 y's, so y to the 6th power. And there's no more z's. Now that we've taken care of all the variables, let's talk about these coefficients. If all you had was 4 over 16, well, you would divide that out. So 4 divided by 16 makes 1/4. And the variables just tag along. Okay. Now let's look at some negative exponents. What does a negative exponent mean? Well, a negative exponent basically means that the base is at the wrong side of the fraction. So if we look at example 5, 2 to the negative 3, I can't expand a negative 3 power. I don't know what that means. 2 to the third, I can expand as 2 times 2 times 2, but I can't expand 2 to the negative 3. So if I make this into a fraction over 1, because everything has a pretend division by 1 in the background, I'm going to move 2 to the negative 3 power. The negative exponent is telling me that the 2 is in the wrong place. So that means it should be at the bottom of the fraction. So 2 to the positive 3 is at the bottom, And in the numerator, since there's nothing left, we put a 1 as a placeholder. So when you move negative exponents, when you move it to the correct side of the fraction, you make the exponent positive. So let's say I had the other way around. What if I had 1 over 2 to the negative 3 at the bottom? So this would be saying that 2 to the negative 3 should not be in the denominator, it should be in the numerator. So this would change to 2 to the positive 3 over 1, which we know is just 2 to the third. Now, we can keep simplifying both of these. 2 to the third is 2 times 2 times 2, so 2 to the third is 8. And if I look at the green example, 1 over 2 to the third would be 1 over 8. So negative exponents simply mean the base is in the wrong side of the exponent, of the fraction. Let's look at example 6. So for example 6, I see some negative exponents here, plus I see that this is being multiplied together. Well, I'm going to look at these individually. So this is really all over 1, and this is also all over 1. So I'm going to find the bases that have negative exponents attached to them and move them to the other side of the fraction. So I see that y to the negative 8 is a negative exponent, so we're going to drop him to the bottom of the fraction. I also see that x to the negative 5 is a negative fraction, so we're going to drop him to the bottom of the fraction. Now, the negative 3 out front is fine. That is not an exponent. This is a coefficient, and coefficients are allowed to be negative. Negative 3 just means a subtraction of 3. So those are fine where they are. So this first fraction is now negative 3x squared divided by, and in the denominator is y to the positive 8, times the second fraction is 5y to the 6th over x to the positive 5. So now that we have changed our negative exponents to be positive, this is something that we can work with. So let's use our expansion to help us simplify this problem. So this becomes negative 3x times x times 5 y, 6 y's, all over 8 y's and 5 x's. Now, why is this able to just be multiplied in one giant fraction is because that's how you multiply fractions. The numerators get multiplied and the denominators get multiplied. Now let's see if we can maybe get rid of some of the same variables. I see that there's an x, and then there's an x and an x. Let me fix that one. X, here we go. And I also see that there's a y here, y here. There's a y, there's a y, there's a y. So we're going to get rid of all the pairs that we can. And this is my last pair, and I've run out of y's on top and bottom. So what we have left is we have negative 3 times 5, and there's nothing else on the numerator. That's all I have left at the top. Over, there's 2 y's, so y squared times 1, 2, 3 x's, x to the third. So to finish off this problem, we're going to multiply these two together. Negative 3 times 5 makes negative 15 over y squared x to the third can't be done. Nothing else can be done with that. However, we can put it in alphabetical order. So we always like to put our variables in alphabetical order. So x to the third, y squared. I want you to pause the video, use what you've learned so far, and I want you to try out example number 7 on your own. And here's your solution for example number 7. Let's look at example 8. So example 8 is a little different than the others because it has an exponent raised to another exponent. Well, this outside exponent here is telling you how many times x to the fourth is being multiplied together by itself. So this 3 out here is telling me that I have x to the fourth times x to the fourth times x to the fourth. Now, I can keep breaking this down. I can keep breaking this apart, and I can say that this first x to the fourth is 1, 2, 3, 4 x's all multiplied together, times the second x to the fourth is another 4 x's all multiplied together, times the third x to the fourth is another 4 x's all multiplied together. Since there's not a fraction, I can't get rid of any x's. I can't simplify these by doing something over itself, so we're just going to have to combine all these back up. So how many x's do you have multiplied together In total, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this simplifies down to x to the 12th. Now, does that work the same with fractions? Yes, it does. So if you have, again, this 2 on the outside is telling me that I have 2 of these fractions multiplied together. So 2a to the 5th, 2a to the 5th over b to the 7th times 2a to the 5th over b to the 7th. And again, I can break this down further. This first fraction is 2 5a's over 7b's. That's the first fraction. Times the second fraction is the exact same thing. 2 5a's over 7b's. Now, when you multiply fractions, remember, you're multiplying straight across. Well, unfortunately, there's all the b's are at the bottom. There's no b's on top, so I can't get rid of any b's. Same thing with the a's. All the a's are on top. There's no a's on the bottom, so I can't get rid of any a's either. But I can do 2 times 2, which makes 4. Then I have 5 A's times 5 more A's. So how many A's are being multiplied together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have A to the 10th over, I have 7 B's times 7 B's. So how many B's are being multiplied all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So B to the 14th. I want you to pause the video, try example 10. And here's what you should have had for example number 10. Pause the video and try example 11 on your own as well. Here's what you should have had for example number 11. Now let's talk about when something is raised to a power of 0. We know what something to the first power is. Something to the power of 1 is just the same number. Something to the power of 0, though, is a little bit different. Let's back up and let's talk about a couple things first. If you have 2 to the third, you will probably agree that that is 2 times 2 times 2. If we have 2 squared, that is 2 times 2. 2 to the first is 2. So what in the world is 2 to the 0? So let's kind of analyze what I've written down. If I have 2 to the third, the power tells me how many 2's we have multiplied together. So there's 3 2's here because of this 3. 2 squared means there's 2 2's here because of the 2 at the top. 2 to the first means there's just 1 2. 2 to the 0 means there are 0 2's multiplied together. Well, 2 to the 0 is actually equal to 1. Now, where's that 1 coming from? Well, just like it's always been there. So when you think of x, there's always a 1 in the front that nobody writes. There's the same thing going on with these. There's a 1 multiplied to all of these 2's that nobody writes. He's working behind the scenes. And the reason he is behind the scenes is because even if you multiply 2 to the third times 1, you still get 2 to the third. He doesn't really do much. And so same thing here. I can do a 1 times and I still get the same thing. There's a 1 times a 2 here. The problem is the moment I have 2 to the 0, there's no 2's left to steal the spotlight of the show. So this 1 has to come out from behind the curtains and actually show himself. So 2 to the 0 is really a 1, and that's true for anything. Anything to the power of 0 is equal to a 1. So now let's look back at my example for number 12. If you have all of this crazy giant fraction, all raised to the power of 0, that means there are none of these multiplied together, and all you have is the pretend 1 that nobody writes. So something to the 0 power, even if it looks as crazy as it does here, is simply equal to 1. Now, what if you had something more along these lines? What if I had x to the 6th times y to the 0? Well, x to the 6th does not have a power of 0, so this has to stay x to the 6th. But y to the 0, well, that's equal to 1. So I can simplify y to the 0 and write a 1. X to the 6th times 1, though, is simply just x to the 6th. So just because you see a 0 exponent doesn't mean the simplified answer is a 1. It means that whatever's attached to that exponent of a 0 is equal to 1. That's the difference. So here's a quick summary of how these exponents work. Coefficients do what they're supposed to do, multiply or divide. If the bases are side to side, you add their exponents together. Bases are top to bottom, you subtract the exponents. Negative exponents move to the opposite side of the fraction and become positive. An exponent of 0 equals 1.